Excuse me, ma'am, your mic is mute.
Very good morning, ma'am.
Good morning.
Good morning to all the participants. I hope my screen is visible. Good morning to Aditi, ma'am. I welcome all the participants to the third day of this faculty development program on new approaches in geotechnical earthquake engineering. And we welcome Dr. Aditi Singh, ma'am. We are fortunate to have her with us today. And she is an assistant professor and program coordinator for BTech in the Department of Civil Engineering, Sarla Birla University, Ranchi. She is a doctorate, graduate, and postgraduate from Gautam Buddha University, Greater Noida. Her research field includes disaster management, landslide hazard, vulnerability, and risk assessment. She has pursued PhD on landslide hazard, vulnerability, and risk assessment in and around Gopeshwar Township of Chamoli district, Garhwal, Himalayas. She has a research experience of around 5 years with several national and international research publications in SCI index journals and reputed book chapters. She has also had the opportunity to present her research at the international conference in Slovenia, Europe in 2017 at the Fifth World Landslide Forum. She also participated in 2 weeks high-level course in IRA, International Research Association on Large Landslides School, that was at the Chengdu University of Technology, China. She is also engaged as a reviewer for several international journals of high repute. We welcome you, ma'am, on behalf of IPS Academy, Institute of Engineering and Science. We are thankful that you could manage time out of your busy schedule and enlighten us, ma'am. And we request you to please take over the session, ma'am. Ma'am, I hope this screen sharing option is active at your side.
Yes, ma'am. Thank you so much. Now I'm going to share my slide. Is my slide visible?
Yes, ma'am, it's visible now. Ma'am, I request you to put it in the full slide mode, ma'am.
Yeah.
Yes, ma'am, it's clear now.
Okay, thank you so much. Good morning to all the participants. I'm Dr. Aditi Singh from Sarla University, and today I'm here to give my presentation on landslides and disaster management. So, with this topic, I'll be first giving a brief introduction about the GIS, remote sensing, which plays a very crucial role in the disaster management, then its application part. Then I'll be discussing about the landslide, and within that, I'll be discussing about the landslide susceptibility zonation and physical vulnerability of buildings exposed to landslides along with a case study. So with that, the first topic is remote sensing. So it is a science uh, and art of obtaining information about an object, area or phenomena through the analysis of data acquired by a device that is not in contact with the object, area or phenomena under the investigation. So science because it involves scientific principles behind it. So it's a science and art because it depends upon the skill of the interpreter, how nicely the data is being interpreted. And for that, we need to obtain information about three basic things, that is object, area, and phenomena. Object, like some buildings of interest, that is the features we are working on, and area like multiple features in a region, example a city, agricultural field, etc. Then the third one is phenomena, that is which is happening in real time, such as rainfall or some disaster. So you are all hearing me and watching these slides. It is also a kind of remote sensing, right? So now why remote sensing? So it enables us to give information like systematic data collection, information about three dimensions of real objects, repeatability and global coverage, and multiple purpose information. So systematic data, like I'm going to obtain information for something, some area, and I'm going to send 10 people for it to collect the information. So 10 people will have different set of data and 10 different types of error will be there. But with this systematic data collection, that sort of error can be removed. Repeatability, like taking information about certain period of time, and for global coverage, like sometimes a disaster is taking place and we are not in that position to physically go to that place, so in that case remote sensing is very helpful. Then the same data can be utilized in different methods for people catering to different application, so same information can be used for different application. Now, next we resort to remote sensing process. What is the process? How we are able to get the data? So, the first of all, we need to sense some target which we want information, and with a source of light, which is the sun, which needs to be illuminated. So it can be sun or some artificial source of energy. Then we need a sensor to collect and detect the data. So D is our sensor, which is a platform. Then once the information is recorded on board, we need to disseminate this information to the ground, and which we call as ground receiving station. In India, we have this station in Shadnagar, which is in Hyderabad. And then once this information is collected in the ground station, that is E, this information is pre-processed. That is, we are removing certain known errors and giving it a valuable format which the users can easily use. Uh, and then followed by different applications for like land use, atmosphere, hydrology, geology, forestry, agriculture, and of course the disaster management. Then comes the next term, which is GIS. So GIS, we are all using it. It is a computer-based tool to capture, store, update, analyze, and display all forms of geographically referenced information on Earth. And this information is acquired in for the real life problems. So originally GIS was developed in Canada for farmland revival and development, and then later it was utilized for various other purposes. So the most commonly used softwares to carry out this work are ArcGIS, which is a licensed software, and then we have is QGIS, which is an open source software. So people can use it openly without having any key or access like that. Then for GIS, we are going to have 5 basic components, that is the hardware, software, data, methods, and people. So hardware, that is the robust computer system, is a must for smoothly performing all the operations in GIS, and this is the basic requirement to start with the working. Then we require a software like ArcGIS and QGIS for storing, processing, analyzing, and displaying the data. Then for the data, the final GIS output are largely depending upon the availability and quality. So the input data for GIS may be in the form of satellite images, scanned maps, survey data, historical records, etc. Then for utilizing that data, we are going to require methods. There are a lot of methods used in GIS to work upon, like the numerical rating scheme, ANN, that is the artificial neural network, fuzzy logic, etc. So the selection of the method solely depends upon the kind of work that the researcher is doing or upon, and so the method should be selected according to the requirement, which also saves time, money, and will be providing a very good result. The next is the people for which the system is being developed. So there are a lot of people who are involved in it, like the GIS manager, specialist, surveyor, managers, and the end users. Now, we all are aware that India is one of the most disaster prone country in the world. So that for that we are going to have a strong disaster management plan. And for that, remote sensing and GIS is playing a very incredible role and providing an effective tool. So remote sensing and GIS in the disaster management means a range of activities before, during, and after the disaster to reduce its impact. So there are few pillars of disaster management, four pillars basically, which is mitigation, preparedness, response, and recovery. So first is the mitigation. So in the mitigation phase of remote sensing and GIS technology, it is going to provide the capability to map and analyze hazards of all types, and then it will provide a better visualization for their potential impact. Therefore, in this phase, we can identify and map all types of hazards, then identify and map critical infrastructures such as hospitals, public assemblies, schools, etc. And then we can develop site-specific strategies to reduce the losses. So that was for the mitigation. Then we have with us is preparedness, which is selecting and modeling the evacuation routes. So we develop plan of action when disaster strikes, and then identify and map the nearest hospitals, public safety facilities in that. The third pillar of disaster management is the response, and it provides warning and notification to the people and also maintain the incident status in the form of damage assessment, data collection and analysis. Then the fourth pillar is the recovery, that is to restore the affected area to its original state. For example, by providing the temporary housing, medical care, and grants to the people who are affected by the disaster. So, for the disaster management, we are going to require a space technology. So, space technology provides a platform for observation and information. And in this information is very useful for taking proper decision in the event of disaster, and not just the observation, which is more or less spatial, but it also provides satellite based location, which is popularly known as GPS. And GPS is nothing but a satellite based location service provided by a group of satellites which were launched by the US. Then the third aspect in this is communication, which is which in the event of disaster, the terrestrial communications are affected first. So in that case, to understand the extent and location of disaster, as well as getting the ground-based information for the prioritization, communication in the period of disaster is mostly provided by this space technology. So in a disaster cycle, as we have already discussed about the four pillars of disaster management, there is a cycle in a disaster management. So first, information and observation is provided by the satellite-based information, which is observing the Earth, and the satellite-based communication from the ground to assess the extent of the disaster and the damage which is caused. Then we extensively use satellite-based location service to reach out to the places which have experienced a disaster to provide the relief and rescue. Then comes the rehabilitation. Here also the extent and amount of damage is assessed mostly through space-based observation. Then comes the reconstruction and mitigation. And finally the lesson learned from the disaster translated to the preparedness, both in terms of early warning system as well as the information development for pre-warning of an impending disaster. What are our space-based observation which will help in the observation of the Earth? So we have a set of satellites which are designated for different functions. We have land and water observation through a series of satellites, mostly the ResourceSat and the microwave satellites such as ReSat. Then we have a series of high resolution satellite to identify the infrastructure level damage, for example, the Cartosat and ReSat. Then for the oceans, mostly which senses the temperature, the salinity, as well as the wind velocity and direction. We have OceanSat, SCATSat, CEREL, etc. Now, one of the most important group of satellite for disaster management are the weather or climate satellites, which are mostly geostationary. So it provides very high temporal information and it is mostly used to monitor and track the events like cyclone, tornadoes and other weather related disasters. So presently, which we have the imaging capability from very high temporal, almost giving images to every 15 minutes at 1 kilometer spatial resolution to a very high spatial resolution of zero 0.8 meter, which can be effectively used to identify the infrastructure. And we are continuously augmenting this capability from time to time. Now, for the information to assess and collection of the data, we have various portals in India, which is providing a data set in the form of satellite imagery or maps. So we have Bhuvan, NDEM, MOSDAC, and IMD. So Bhuvan allows us to explore a set of map-based content prepared by ISRO. Then NDEM, that is the National Database for Emergency Management of Disaster. It is a portal provided by ISRO again and the central and state departments, and it provides products and services for better management of disaster. Then MOSDAC is the Meteorological and Oceanographic Satellite Data Archival Center, and it is the data repository for the missions of ISRO and the government of India dealing with the meteorology, oceanography and tropical water cycles. Then IMD, we all are aware of, we are constantly looking at the weather, temperature each and every day. So very basic site and everyone is following it, which is the agency of Ministry of Earth Science and Government of India, and it is responsible for the weather forecasting. This is the IMD website of India, which is for the current and forecasting meteorological information. Then this is the cyclone warning, cyclone forecasting. That is the early warning system by IMD. So we have tackled various problems of cyclone like Amphan and Nisagra through this technology. Then we have again storm, which is the system of thunderstorm observation, predicting and monitoring for predicting the lightning, heavy rain, gusty winds, etc. and within a 24-hour lead time. Then we have for drought, we have this deuce, and for the forest fire, which is very prominent in hilly regions, so we have forest fire reporting mobile app, which is developed by ISRO, and it will prove to be an effective tool for the forest management, where satellite will do the validation of forest fire, and points accurately, and this will help the department in taking appropriate actions in controlling the fires. Then we are all aware of it about the drones. Drones are also being used for collecting information and monitoring. For example, in the containment zone in the times of COVID, which is also, so these are some of the examples of the application of remote sensing and GIS in managing the disaster. So, concluding the role of remote sensing and GIS in disaster management, the first point will be the hazard. The hazard maps can be created for various natural and man-made hazards like floods, earthquakes, cyclones, forest fires, etc. Then it can map the affected locations and compare the data to historical information to assess the overall damage. Uh, while remote sensing aids in map preparation, GIS can be used for the storage of digitized map, their visualization and analysis. Uh, then it helps in all the stages of disaster management, as we all have seen with some of the examples. Therefore, it effectively improves the workflow in all the phases of the disaster management. So this was all for the various tools, techniques we are using for disaster management. Next, we are going to come upon the topic, that is landslides. So landslide is one of the most damaging and life-threatening hazard which affects most of the hilly regions worldwide. Landslide is the movement of mass of rock, debris or earth down the slope under the effect of gravity. And as per the reports of Annual Disaster Statistical Review 2016, China, US, India, Indonesia and Philippines are found to be the most frequently affected countries. Then, according to a study which was conducted by Froud and Petley, uh, from 2014 to 16, there are individual landslide events you can see, and from that study, it was concluded that majority of landslides were triggered by rainfall, that is 75%, of which India is contributing 16% in the global data set. So you all can see over here that this in Indian country, India, there are so many landslide events that have happened from 2004 to 2016. So from the study, it was also concluded that 28% is construction triggered landslide events, and about 12% is landslide events triggered by mining, and 30% of the landslide events due to the construction activities along the road. So construction activities is most prominently triggering the landslide, whether it is the construction of roads or the residential buildings and other type of construction. This landslide, a case study has been presented on which two objectives have been fulfilled, like for the study of landslide susceptibility zonation and for the physical vulnerability. So the study area on which the study has been conducted is Chamoli district, which is in the Gopeshwar township, and Chamoli is the district headquarters. And Gopeshwar Township is the district headquarters of Chamoli since 1960. And since it shares the international boundary with China, it is important from strategic point of view. So this is the map of Gopeshwar Township, which is obtained by Nagar Palika Parishad Chamoli 2016. And according to the municipality, Gopeshwar Township has been divided into 11 different wards. So this township has been divided into 11 wards. And as you can see, this is the photograph of the township, which is one is from government website, and the other one is the field photograph. From this, you can see that the buildings are built in clusters haphazardly and without any township planning. So, being the district headquarters, the study area is densely populated. Uh, and hence the majority of the buildings are, as you can see, are non-engineered, and they are so much of built-in clusters over here. And these are the typical examples of the buildings which are found in the study area. So these buildings can be um, unreinforced buildings, RC buildings, stone masonry, brick masonry. Some are having single story, some are having double story. Then on there is also a mixed type of construction over there. Some half is brick wall, then other is sheets. They have made using sheets. Then half is brick masonry, as you can see over here, which is not at all proper. Then this is the satellite image of the study area, which has been collected from the GIS, and from there we have observed that there are 5 landslides which are affecting the area, and we have given the notation to each one of the landslide, like LS1, 2, 3, 4, and 5. So these are the landslides, we have given the notation. So in the study area we are affected by the 5 landslides. uh, as you can see here, it is a this is the field comparison of the images acquired from field survey, which is on the left, and then which base map ArcGIS, which is on the right. So first we collected the data sitting in our offices from the Google Earth images and ArcGIS maps. We have identified these landslides, and then for ground truthing we went to the field where we found the exact that these things are true. So this is just a comparison to show that data acquired plus the ground truth, um, what is the condition. Then these are the two landslides, LS1 and LS2 of the study area. Then this is the third landslide, and third and fourth landslide. So in this study we have made a study only of the 4 landslides, and the fifth one was not reachable physically. So we have conducted only on the fourth landslides. So the first study we did was the landslide susceptibility zonation. So it is done in order to acquire the prior information on the probability of landslide occurrence in hilly areas, and generating the landslide susceptibility zonation maps, which is necessary. So basically it is the first objectives in all landslide studies. And landslide susceptibility maps basically divides the landslide prone regions into various level of susceptibility zones. These things, so susceptibility, it is the likelihood of the landslide occurring in an area on the basis of the local terrain conditions. And while dividing these areas in different categories, like very high susceptibility, moderate susceptibility, low and very low susceptibility. So these are all the different categories. We divide the regions to know the how susceptible is the region, how prone is the region to landslide. Then there are different methods to carry out this landslide approach. Uh, Broadly, it is classified as qualitative and quantitative. So, under qualitative, again, there are different methods like distribution analysis, geomorphic analysis, map combination, and quantitative, which now people are mostly using it, like AHP, fuzzy, machine learning, ANN, information value, weighted overlay. These are all the quantitative methods. So a lot of study has been already been carried out on landslide. So in my study, basically, this is the flow diagram of the steps which have been followed for the landslide susceptibility zonation, and in this, information value approach has been used. So for the input data, I have taken data from published literature, field data, Cartodem, which is the satellite image, Google Earth, base map imagery, and ArcMap. Then from these input data, the different thematic data layers corresponding to different corresponding Factors for landslide occurrence have been prepared using GIS and field data like slope, aspect, drainage buffer, TWI. And after collection of this data, the data is being integrated using the information value technique. And finally, this has been the study area has been classified into 5 different zones, that is the very low susceptibility, moderate, high, very high susceptibility zones. So this is the study area, and in this layer has been created using the GIS using KML at 10 into 10 meter pixels, and 5 major landslides were identified on Google Earth and are further aided by field verification. So in this, 4 are debris flow type of potential failure, and one is the this is which is the rockfall type of potential failure. So within this GIS, we have used this tool to calculate the area of the landslides and the whole area where we are going to study. So these red marks you can see, these are the landslide distribution layer. So these are all the different layers we have studied in this. So the LULC, that is the land use land cover layer. Then we have is slope, which is the angle formed between any part of the earth surface and the horizontal datum. So it was observed that the slope category of 25° to 35° has the highest incidences of landslide. Then we have the aspect layer, which is the direction of maximum slope of any location on the earth's surface, and it is related to the distribution and density of vegetation on the mountainous slope. So in this study, it was observed that the southwest aspect category was having the higher percentage of landslide occurrence. Then next is the elevation layer, which is extracted from DEM, that is the digital elevation model. And elevation affects the slope material by weathering process. It also controls the runoff direction and the rate of drainage density. So 1358 to 1592 meters have been the is having the higher percentage of landslide. And next we have is the curvature. It represents the morphology, which is the study of forms of things like shape or structure of the topography. So in general, we have 2 types of curvature: profile curvature and planar curvature. So in this, we have studied about the PLC, that is the planar curvature, which is concave, convex, and flat. So the convex is the positive curvature, which is outwards, and the negative curvature, which is the concave. So the study shows that the concave slopes have a higher percentage of landslide occurrence. Then we have next is the drainage buffer, and most of the landslides in the hilly areas occur due to the erosion activities. So drainage layer has been prepared from DEM, that is the digital elevation model, using the hydrology tool, and drainage line has been extracted as per the Strehler's classification, which is a tool again in the GIS. Then next, the last layer is the this thing, topographic wetness index, which is represented by TWI over here. So it is an indicator of the availability of the soil moisture at a site. So the soil moisture is being reflected, and the role of water in triggering the instability in a given catchment. So this layer is again prepared using the GIS, and this is the all the layers have been overlaid and numerically added, and success rate curve has been presented over here. So this is the success rate curve, and it is defined as the percentage of landslide occurrence in any susceptible zone. So five representative, as you can see, these are the five representative factors at which success rate curves have been prepared. So for the success for m equal to 1, the best success rate curve was achieved, and for the first 10% area in very high susceptible zone, the corresponding to m equal to 1 has the highest success rate, as I already told you. So for area under curve is achieved graphically. So the m equal to 1, the success rate is 97.6%. So we have prepared this landslide susceptibility zonation map at success for m equal to 1. Then this is the final LZ map, which you can see here, which has been classified into 5 different layers. Very low susceptibility, moderate, high, and very high susceptibility. So with this visual inspection of LZ map suggests that all the 5 zones are distributed all over the study area, and from this is the all different percentage of landslide. So from this, it can be stated that 13.9% of high and very high susceptible areas together contain 62.34% of the existing landslide areas. So in high and very high susceptible areas, we are approximately having 62% of the landslide. So this is the summary which already I have discussed. Then next we have is the physical vulnerability. So, first we need to know about what is vulnerability. So from natural and engineering science perspective, vulnerability is defined as the degree of loss in terms of the percentage of structural damage to a given element or set of elements subjected to a landslide event of a given type and intensity. And it is expressed on the scale of 0 and 1. So 0 is going to denote that there will be no loss, and 1 is going to denote that the total loss has taken place. Then as per UNDP, that is the United Nations Development Program 2004, this vulnerability, it has been classified into 4 categories, which is physical vulnerability, environmental vulnerability, social vulnerability, and economic vulnerability. So physical vulnerability, it is the loss due to damage of physical infrastructure and buildings, which we have conducted in this study. Then next we have is the environmental vulnerability, that is the loss of natural resources and damage like water, land, etc. Social vulnerability is the loss of population and social structure. Then economic vulnerability, it is the effect on the economic condition. So this is basically the summary of indicators from the literature to assess the physical vulnerability of buildings. So different studies have been conducted in the past, and which they have used indicators like construction material, number of floors, surrounding walls, slope slide, then presence of basement, foundation type, its depth, maintenance, construction year, what is the function of that building, then roof material and the structure, then floor height, number of the openings, material, quality of construction, cracks in the building, building location, presence in between buildings, and protected by the vegetation. So these are all the different uh, indicators. So in this, as you can see, in a single study, not many indicators have been used. Some have used 4 indicators, some have used 5 indicators. So in case of landslide, not much indicators have been used. So the challenges we have faced in assessing the physical vulnerability of buildings is that there is no standardized methodology adopted universally to assess physical vulnerability, which we can see from here. Some have used 5, some have 8, 1, 3, 2. So these are the different indicators, set of indicators they have used. So this shows that there is no standardized methodology all over the world. Then next challenge we have is several buildings to assess physical vulnerability of building due to landslides are carried out from the European countries. But these methodologies cannot be successfully implemented in India because of the difference in geological and climatic conditions. So all these European countries studies cannot be directly implemented. Then the most common setback is the availability of data regarding the building typologies in India. In India, we have the lack of data, so which limits us to use to perform studies on this aspect. So with this, a flow diagram, as you can see here, has been prepared to assess the physical vulnerability of buildings. So first is the built up area mapping, then we have to landslide intensity, and we need two aspects, that is the landslide intensity and the resistance of the building. So resistance is classified into three different categories, that is the 1, 2 and 3, low, moderate, low resistance, that is when based on those parameters, the indicators, we have calculated the resistance. Then moderate resistance when the value is between 0.5 equal to or less than 0.9, and high resistance when it is equal to or more than 1. Then from landslide intensity and resistance, we are going to calculate the physical vulnerability. Then physical vulnerability, we have two cases over here. One is the site specific vulnerability, and the other one we have is the scenario based vulnerability. So site specific vulnerability is basically focused on a single region where we want to focus, and then scenario based vulnerability will provide a general idea that how the area is going to be impacted in case of a sudden intensity of landslide. Then this PV class has been categorized into three classes, class 1, 2 and 3. As you can see over here, buildings have been marked. That is the buildings. These are the different buildings of wards. Ward 1 has been denoted by different color dots, and these are all the different kinds of wards being represented over here. So in total, 542 buildings have been surveyed in this study, and some wards were bigger than the other, so the cluster of buildings surveyed in each ward is not uniform over here. Then for next step was the documentation form for systematic collection of the data of buildings during the disaster, and this is the form which we have used in the study. So in this first indicator is the year of construction, then we have roof design, then structural typology, and surrounding wall of the building. So we have categorized each aspect into different categories, like surrounding wall is strong, high wall, medium or low. Then structural typology, we have stone masonry, reinforced or mixed kind of structure. Then roof design is of what type, then number of floors, vertical configuration, whether the building is regular or irregular. Then horizontal configuration, with again the regularity, irregularity in this horizontally. Then the presence of windows and doors, which should be greater than equal to 1 meter, which is as per the Indian code. Then distance between the two houses, building position from steep slope, that is whether it is less than 10 meter, greater than 10 meter, or on the steep slope. Then the surrounding vegetation, and surrounding vegetation like barren, cultivated, or forest, and the quality of construction like the bulging of walls, spalling of concrete, and whether the reinforcement is exposed or there is honeycombing in the structure. Then other indicators are cracks in the structure due to the movement of slope, then ground settlement, whether it is having ground settlement or not, then the water seepage is present in the building or not, then the type of construction, whether the buildings are engineered, non-engineered, or marginally engineered, and the last one is retrofitted building, whether they have been retrofitted, that means once they were affected by some sort of disaster, earthquake or landslide, and then again retrofitting has been done on that building. So the 15th indicator is the retrofitting. So all these indicators which we have seen over here, they have been assigned with a resistance score, resistance rating. So these are all the different resistance factors which have been assigned to all the indicators, and these resistance factors has been assigned based on either literature or using the Indian Standard Code like IS 1480-2000. So these indicators have been assigned factors. So after the collection of this data in this building vulnerability assessment form, this scores are being assigned, and then these scores are being calculated using this empirical formula, and then they are categorized as low, moderate,
Ma'am, you are not audible, ma'am. We cannot hear you.
Uh, Please wait for some time. I think there is a connection problem. Madam will join again.
Yes. There is some connectivity issue at ma'am's end. We request the participants to please wait for a few minutes.
Madam, we have already sent it on the group, but we will again send it. No problem. Renuka, madam, are you here?
Ma'am, the schedule is shared on the WhatsApp group.
Hello.
Yes, ma'am.
Hello.
Yes,
Yes,
ma'am. You
ma'am.
are audible.
Uh, Ma'am, my slide is visible.
No, ma'am, it's not visible now.
Is okay, okay. Uh, uh, is it
Uh,
still not
no,
visible?
no, ma'am, it's not visible at our end.
Now,
Ma'am, it's appearing. Yes, ma'am. Ekta ma'am has responded that she can see it.
let's go. Okay. So that's sufficient. And after using this empirical formula. Then this is the just a table in which we all can see that it is a ward-wise the resistance factors have been summarized. So this is the resistance class of the buildings which have been shown using the pie chart of different, like for ward 1, 2, 3 until ward 11, different pie charts have been shown which is representing the resistance of the building, whether the ward is having low resistance, what is the moderate percentage of resistance, and what is the high percentage of resistance. So from all this we have observed that ward number uh, maximum resistance, that is the 52%. Sorry, 92% is the moderate resistance and 8% of low resistance. Then the overview of the methodology for the scenario-based debris flow intensity. We are going to have the intensity. So with this, for Indian condition, for Indian Himalayas, landslide intensity has not been reported so far. Therefore, in this study methodology has been proposed to assess the landslide intensity. So scenario-based intensity is assessed based on the debris flow type of potential failure, and based on intensity has been calculated using the velocity, landslide velocity scale, which is provided by the Cruden and Varnes, and then landslide volume for Indian Himalayas, which was given by this by Sarkar sir. So using volume and velocity, we have developed a matrix to find out the intensity. So this matrix shows low four intensity classes have been proposed for different combination of debris flow, volume and velocity. So this is the final outcome of the matrix, that the four categories: low, moderate, high and very high. It has been given a proposed value of 0.2, 0.4, 0.8 and 0.1, which is the very high intensity. So again, as we have already discussed in the beginning of the flow chart methodology, that physical vulnerability is a function of intensity and resistance, and it has been classified into three different classes. So intensity we have already defined using the matrix, and resistance using the different resistance factors by using building vulnerability form. Then for physical vulnerability, three classes are there: class 1, 2, and 3. And this is depicting that class 1 is the low damage, then class 2 is depicting moderate to severe damage, and class 3 we are having very severe to complete damage. So for scenario based vulnerability, we have found that when it is exposed to low intensity, the buildings, all the buildings are safe. Then physical vulnerability at moderate intensity, we have found that physical vulnerability, 64% buildings belong to class 2 and 36% of building belong to class 3. Then when we have exposed the building at high and very high intensity, what we have found is all the buildings are belonging to physical vulnerability class 3. All the buildings are in the mode of very severe to complete damage. That means this study area cannot sustain this much amount of density. So through this, we, as I have said, we consider this to be a landslide disaster, and we will be severely affected by landslides of very high and high intensity. So this was for the scenario-based intensity. Now talking about the uh, site-specific vulnerability, we have focused on a single landslide, which is affected by debris flow. This is the field photograph. This is the Google Earth images, which is blue. Here lines you can see is the drainage pattern when there is rainfall. Then this is the drainage zone, the which is being followed, and all this is going to the Alaknanda River. So this is adjoining river of this township is Alaknanda River. So, and this is the Google Earth image, as you can see. This is again, this is the landslide. This is the Alaknanda River. And these are the different buildings which have been constructed near the landslide. So, comparison of this image has been presented over here through Google Earth. On 28th May, you can see that there is no landslide over here. 25th Feb, a small bit of landslide you can see. Then it is dense vegetation is here. And in 2014 and in 2017, again, there is sparse vegetation and more population. So this is because of the 2013 the flash floods which have happened. So this triggered this. So 28th May there was no flash flood, and after that the flash flood uh, came, Kedarnath flash flood, and this was triggered, as you can see over here. And these are the examples of the buildings of the houses over there, which have these types of cracks. This is the example of the school, which is just above that landslide, and it has experienced these severe cracks, in not only in the walls, but also on the floors over here. Then this is the houses. It is the joints and also on the floor. This shows that there is a certain amount of movement in the ground. So stability is not there, and this portion of the ground is unstable, and it is slowly moving down to the Alaknanda River. So for this, we have calculated the velocity. So velocity was calculated using the area and the thickness of the this thing of the region, thickness of the landslide, and using numerical formula, using that we have used this matrix, and intensity was given. Then this you can see the field photograph. This is the this thing landslide. Another adjoining landslide above that is also being triggered, and these are the different buildings which are the vulnerable. And from this, we can conclude that one of the major advantage of the methodology is its flexibility. And the practical experience achieved through the case study shows that the methodology is user-friendly and can be directly implemented with the knowledge on landslide intensity and resistance ability of individual buildings in the area. And even if the data on landslide intensity is not available, the vulnerability of the building can still be done. That we have researched first. The is developed taking into recommendation of living. However, this can be transferable to other developing countries by adopting their codes and the structural patterns. Then such assessment can be extensively used by engineers and scientists to facilitate appropriate protective measures to both the buildings and the landslides to increase their resistance, decrease the intensity respectively in a particular area. Then this will buildings to also like property, and such types will help with construction guidelines. It will help in preparing the construction guidelines and specific to a particular region which are presently lacking in the country. So these are the different publications related to this work. So one is in environmental development and sustainability with the title An Integrated Approach for Landslide Susceptibility, Vulnerability and Risk Assessment of Building infrastructures in hilly regions of India. Then the next publication is focused only on the physical vulnerability assessment of buildings, exposed to landslides. Then the first overview of this paper on the recent developments, which was presented in WLF, World Landslide Forum. Then one paper is related to the site-specific vulnerability assessment of buildings, which is exposed to rock falls. So these are all the different publications which are related to this work. That is all from my end. Thank you so much.
Thank you so much, ma'am, for sharing your wonderful work of the validation study regarding GIS and remote sensing. If the participants have any question, you are encouraged to unmute yourself, or you can even type in the chat box. Ma'am, I have a question. Uh, Aditi, ma'am.
Yes, please. What is your question?
Ma'am, actually, whenever we go for this remote sensing in GIS, it is difficult to have the data extracted from the website. Can you please guide us? How can we obtain that data from a particular website?
Sure. There are different websites which is provided by Government of India. So since India is having boundaries with certain regions like China and other countries, so for security purpose, some of the data is not being is not freely available to us. So in that case, if you are a researcher, you can write down mail uh, to the agencies, which I have already shared. Like there are portals, you can share it, and then they can provide. So some data which are low resolution data is available to us. So you can download from those portals, which already have discussed in one of the slides in the beginning. You can also
Thank
note it down if you are. So this is the Bhuvan site is basically there. Bhuvan site you can use. And if you are a researcher, then you can write down your mail that I have, this is my area of interest and I am working, my objective is this, so kindly provide the data, and definitely I'm sure they are going to help you out with it. Then other data you can purchase it. So these are free of cost data, some are purchased data. So there you can follow their guidelines and you can go for it. Yes.
So, thank you so much, ma'am. If any of the participants have any doubts, you can please type in the chat box, or you can also unmute yourself. So, sir, ma'am, I don't see any questions in the chat box as of now. And if any of the participants have it in future, then we will revert it to your email ID. And if in the later case, if you have any guidance or queries to be addressed,
Madam,
yes, sir.
ma'am, can I ask one question?
Yes, sir, please.
Sure, sir.
Ma'am, I was just thinking that actually vulnerability assessment we are doing for earthquakes and
Yes, sir.
separately, and for landslides separately. Is it possible to do it in a
Yes.
combined manner?
Yes, sir.
Uh,
Yes, there is a possible way you can integrate both of them. On GIS platform, you can do it. But
so,
first, you have to select the common features in it. Yes.
ma'am,
Like, for
actually,
example, I have talked about the resistance. So, resistance is, yes, sir.
yes, ma'am, please continue. Ma'am,
Okay.
am I
So,
audible?
resistance
Yes.
is basically common in both the things. I have yes, sir, you are audible. So building is common in both. Building is being affected by landslide, building is being affected by earthquake. So the factors like seismic zones, for example, the buildings I have taken, they are already in the seismic zone 5. And the factors I have taken here is basically the landslide. So if we combine these factors, that okay, these factors are also according to my IS code, and So that factors I can use, and then we can generate this thing vulnerability map. For example, the cracks in the buildings, we can go in detail like what is the amount of cracks, what is the state of maintenance in the building, what is the depth of the foundation. So two parameters we can go in depth. In landslides, I have not gone in depth in that parameters, but if we are going to do the combined study, we can go in depth for those things.
Ma'am, actually, what we do for structures to get the fragility curves, we basically go for time series analysis or incremental dynamic analysis, where we get the probability of survival
Yes,
or failure of our building. So that data we
right.
are having with earth for earthquake. Now, suppose if a building is in a landslide prone area, and
Right.
it may be possible that during earthquake the landslide may occur. So, so what will be its combination actually? It will be a good study if we combine them together, so that to get the real data.
Yes.
Ma'am, you are not audible, ma'am.
So, so for so for that we have to formulate again this thing a methodology, because for physical vulnerability of landslide I have this sort of hello,
Yes, ma'am. You are not audible in between, ma'am.
am I not audible?
No, you are audible,
Hello,
ma'am.
sir, your
Yes,
voice
ma'am.
I am able to hear.
Yes, ma'am. We are now hear you.
Ma'am, am I audible
You are
there?
audible, ma'am.
Renuka ma'am.
Madam, in between you are audible, but
Ma'am,
What,
probably there is some network issue. We are
now
unable to hear
I'm
you clearly.
audible?
Ma'am, the voice is a bit breaking, ma'am. Probably because of
Okay,
some network
okay,
issue.
okay. Okay, so I was saying that, okay, okay. So I was saying that for that we have to prepare a separate.
madam, we are not getting your voice now.
Okay, so I was saying that for that we have. Uh, okay, okay. So I was saying that for that we have to formulate a methodology. Am I audible now?
Yes, ma'am. Yes, ma'am. Yes.
Okay, okay, sir. Okay, so I was saying that we have to integrate the two factors like acceleration and all for fragility curves. So in the physical vulnerability landslide case, we did not have a fragility curve. So fragility curve is another method. So we can opt for that, and then we can prepare the vulnerability map. So while preparing this physical vulnerability landslide, different methods are available with us. One of them is fragility curves, another one is indicator based approach. So in our case, due to the lack of data, fragility curves are not available. So we used indicator based approach, which we ourselves can collect and go to the field. So for your case, we can go for the fragility curve as it is available with us. So we
Yes.
need to first provide a framework and then we can work.
Sure, madam. We can do it. We will try to do it.
Yes, sir. Yes, sir.
Ma'am,
Okay.
one more request. If you can switch on the camera, we would like to see you in person, ma'am.
Oh, okay. Actually, I was not switching it because of the network issue.
Oh,
Because I
yeah.
thought that this thing might not work together. So, is it
Okay.
visible? I have switched on the camera, but
No, ma'am, we cannot see you.
no. Okay, that was the reason because again there was the network
From
issue.
some network issues, ma'am.
No,
Ah,
no problem, ma'am. No problem. Uh,
Okay, no problem, ma'am. We would love to have an interaction with you in future again. And we
yes.
thank you on behalf of the Civil Engineering Department at IPS Academy for giving us a wonderful explanation of the work that you have done, and as well as giving us an inspiration that future studies can also be done in a similar way. Thank you so much, ma'am, for devoting your time and experience with us. And
Thank you so much, ma'am. I would also like to say I'm sorry for the inconvenience due to the network issue we are facing.
no,
But
ma'am, that's it's okay, ma'am. It's nothing at your side, but it's just a technical problem. We cannot. We all are just bound with technology.
yeah, right, right. Okay,
So
thank you
thank
so
you
much,
so
ma'am,
much,
for
ma'am.
having me.
We
Thank you
hope
very
to
much,
see you
ma'am.
in future again, ma'am. Good morning, Pankaj sir.
Am I audible?
Yes, sir, you are audible, sir. Sir, am I audible, sir?
Hello. Yes, yes, you are audible, and very good morning to all of you.
Good morning, sir. Sir, should we start in 5 minutes, or as you say, we are ready to start now also?
That is on you, ma'am. I'm ready.
Okay, sir. So we'll take a break of 5 minutes and then we will start in at 11:20. Is this okay, sir?
It is okay, ma'am. It is fine. Thank you.
So the participants are requested to be ready for the next session, which will be starting at in a few minutes. If you need a break, you can just freshen up and get back soon. A very good morning to all the participants of this 1 week online faculty development program on new approaches in geotechnical earthquake engineering. We are fortunate and privileged to have with us Dr. Pankaj Bajaj sir. He is assistant professor at the Department of Civil Engineering, NIMS University, Jaipur. He is a doctorate from NIT Raipur. He has worked as a site engineer from 2011 to 2012, and from 2014 to 15 he worked as an assistant professor in civil engineering department at JMIT Radour, Haryana. From 2020 to October 21 he also worked as an assistant professor at NIT Raipur, and he has recently joined NIMS University, Jaipur. He has around 11 publications of journals and conference, and he has pursued his doctorate on study on vertical piles, batter piles, and pile groups subjected to lateral uplift and combined loads in non-cohesive soil. Sir, if there is, I suppose the introduction part covers all your expertise, but still, I would like to add if you have anything to be added, sir, please, I request you to do it. And
No, no, that,
we are thankful to you,
this
sir.
this is fantastic. Thank you so much for having me. It is actually my pleasure that I'm giving a lecture on
No, sir, the
this
privilege
topic.
is all ours, and we thank you for taking out time from your schedule and enlightening us, sir.
Okay, I'd like to share my screen. Could you please tell me
Yes,
that
sir.
if it is visible to all of you and I'm clearly audible to all of you?
Yes, sir, it's visible, sir. And
Visible.
sir, if possible, for just a moment, we would like to have the camera on, sir.
Okay, that is fine. So, am I visible
Yes,
to
sir.
all of you?
Yes, sir, you are absolutely visible,
Welcome,
sir.
sir.
Thank you
Welcome,
so
sir,
much.
and
Thank you so much for
glad to
having me.
have you with us.
So, if everyone is ready, with your permission, I
Yes,
can
sir.
start.
Yes, sir, please, sir.
If you want me to switch it on for during my lecture, then I'll keep it this way only.
No,
Otherwise,
sir,
I
it's
can.
it's okay. It's okay. We can have the interaction at the end of the lecture, sir.
Okay, thank you so much, ma'am.
Thank you,
So
sir.
now I'd like to share my screen and uh, let me just tell me that whether it is visible so that we can start. Okay, is my screen visible to all of you?
Yes, sir, it's visible, sir.
Okay, and obviously I'm audible to all of you. Thank you so much. So I'd like to just say one or two lines about me. As she, ma'am, has already said everything. So I have completed my PhD from NIT Raipur in 2020, last year. From July 2020 to October 2020, I was working as an assistant professor there. So now recently I joined this. There is an university in Jaipur, that is National Institute of Medical Sciences, and that I have joined as an assistant professor in civil engineering department. So my PhD is on the is in geotechnical engineering, and the topic of my PhD was already has said that it was on better piles. So I'm here to give a presentation on expensive and collapsible soils. So very good morning, all of you. So let's start with the expensive and collapsible soils. So what I would like to tell you, first of all, we will discuss about the expensive soils, then we can have a discussion on the collapsive soils. So expensive soils are the soils, as you already, as all of you might know, that there are some soils uh, which is having some problem, which cause some problems to the geotechnical engineers, but they are also important because whenever we have such soils, it provides us more challenges so that we can develop a new way of remedification or mitigate, can we mitigate these. So there are some soils which are uh, known as expensive soils. So what are expensive soils? The soils in the soils which expands when water is added in these type of soils, and it starts to shrink when the water content reduces. So what happens when we add some amount of water, it all goes up to the saturation level. When the soil is fully saturated, then what happens is it's try to expand as much as possible, or it will try to swell as much as its capacity. But what happens is when these soils are dried, in that case, it starts to shrink, and which leads to the development of the cracks. So we will discuss about this in the coming slides. So basically, the mineral which is found in these type of soils is montmorillonite mineral, which is basically responsible for the swelling of the soil. So these there are actually certain minerals, clay minerals, or certain minerals that present in others as well. So, like kaolinite, elite. But for swelling of these type of soil, Mont Morinolite mineral is the mineral which is responsible for the swelling of this type of soil. So these where these soils are found, these are found generally where the water table is quite deep, and these soils are generally very dry in nature. So where we can find them. It is a large part of central India. As you all might know that some parts of the Madhya Pradesh and Maharashtra also, some parts of Chhattisgarh as well, and southern parts of India, they cover this type of expensive soils. As is written here that in central India and part of southern India. So these soils are found in these parts of India. So, this soil, we cannot say that this soil is always a problem causing one, but it is, as we can say that for growing of cotton, these soils have a good possibility that we can grow cotton in these type of soils. In generally, these parts of India, we grow cotton. So, but as we can say that these are very harmful for the foundation, or precarious to the foundation of a structure. So as you can see, this is one of the expensive soils found in central region of the India. So there is a pen for the demonstration purpose. It is shown. It is there. So as you can see, when what happens when these soils get dry. So in in this case, what happens is there is a pen, as you can see. So it is showing the cracks in this is such soils. So the size of the crack or the width of the crack can go up to 10 centimeter to 15 centimeter. It can go as high as 15 centimeters. So that is a quite a large number. And depth of this crack can go up to it can go up to zero point 0.5 meter to approximately 2 meters as well. So this you can imagine that if any crack any foundation is laid on such kind of expensive soil, so what will happen in this case if cracks appears on in this type of soil? So probably that building will lead to cracks, or it can also collapse because it will lose its shear strength. This soil will lose its strength, and obviously this will lead to the uh, deformation or any damages to the. It will ultimately lead to the damages to the building. So okay, so actually, this is there is an active zone we talk about in these kind of expensive soils. So active zone, as you can say, it is the zone where moisture, when moisture enters in this kind of soil, so there is a periodic change which happens. So up to which level the periodic change is happening, or it is either it is swelling or it is shrinkage is happening in this kind of soil. So that zone is known as active zone. So active zone is basically, this is a picture taken from K.R. Arora Foundation, Soil Mechanics and Foundation Engineering book. So it is actually different for different locations, but according to the Central Building Research Institute Roorkee, the active zone depth of the active zone is approximately 3.5 meter. So this is basically, as you can see in the figure itself, that active zone is written. So generally, it is obviously, as it is written, that for different places, different location, it is having different depth. So, this is the most common depth of the active foundation, active zone. Sorry. So this up to this level, you will expect the most changes which is going to happen. So let's okay. So let's just discuss about the classification of these expensive soil. So expensive soil, obviously, these type of soils have large clay content, and when it get dry, shrinkage cracks appears. That is what we have already discussed. So various investigators classify these soils based on the index properties such as plasticity index. There are actually various researchers have classified this type of soil according to these index properties such as shrinkage limit, linear shrinkage, swelling potential. So one of the researchers, which is known as Chen, in 1988, he has said that what we have to do is we have to calculate the plasticity index of the soil first. So liquid limit and plastic limit is known. Then we can calculate the plasticity index. From there, where it is classification is there. So if plasticity index value is less than 10 percent, obviously, so the degree of expansion will be low, and the value that lies between 10 to 35, it will be medium. 35 to 55, it is high, and greater than 55, it is quite high. So when Mount mineral light mineral is present, like such soils are black rotten soils and bentonite type of clays. So in that case, what happens is the plasticity index in such cases are quite high. So degree of expansion is also quite high. So and generally, these soils are classified as CL, where it represents as CL. C means clay, and L is having low plasticity. I means intermediate plasticity, and high H means high plasticity. Okay. So generally these are having these soil is having higher clay content in it. So that is why they are represented by CL. Some soils which are having silt content, they are also higher than the clay content. Then it is distinguished. It is classified as ML. M here represent the silt. Similarly, L for the low plasticity. Similarly, I and H for the intermediate and high plasticity respectively. So these type of soil generally show the expensive behavior. So now we will discuss about the probable causes which which leads to the expansion or the shrinkage of the soil. Swelling and shrinkage are the properties and what are the reason behind these things. So let us discuss with this is first one is the variation of the water table. Obviously, you know that when water table lowers down, then in that case what happens is soil will get dry. In that case, soil will try to shrink. So some leakage of water pipelines or pipes will lead to the addition of water content into the soil. So that will lead to obviously to the swelling of the soil. So due to landscaping and irrigation of lawn means watering when we are having and these type of soils, we must avoid these type of lawn watering of the lawns and kitchen. We are making kitchen garden and watering it. So these type of things should be avoided when we have made a house or any building on the expensive soils. So temperature effect is also there. When winters the soil doesn't get dry, but in summer it get dry. So with drying it will lead to the shrinkage of the soil. And when we remove the vegetation, the transpiration stops. And also this thing also happens, the water infiltrates to the ground. Water, when it will go into the ground, swelling will occur. So these are the probable causes of the moisture change, or water addition of water, or any drying or addition. So this will lead to our serious, this can lead to a serious trouble while going for a foundation, for formation, construction of a foundation. So okay, so let us so let us discuss about the if we have already, if we already have made a building on this type of soils, so what can happen in that case? So obviously, let me just tell you that in such cases, when expensive soils are available, so in such cases, what we prefer is, we prefer to go for the strip footing. So, like as you can see, there is a strip footing here. So, if proper measures are not taken while construction of the building, means soil modification or any other things have not been taken care of. So in that case, what will happen is, obviously, expensive soil is there. When water will, in any case, when water will happen in, water will seep into the soil, that will cause the expansion of the soil, obviously, and it will try to push push the floor or slab which is laid under. So that will ultimately lead to the cracking. So as you can see in this picture, that this is a foundation that we have made, but there is a wall which was constructed on the top of this foundation. So what happened in this case is, this soil, when water is added in such soils, the soil try to expand, and in while expanding, it the uplift load was applied on the floor, and which leads to the bend, which leads to the any deformation, or you can say cracking in the wall. Ultimately, floor will move in the upward direction, and this will lead to the crack in the walls. So any change in, any change here, as you can see in the foundation, that will lead to the, obviously, changes in the this wall, and it will lead to the cracks. So that will ultimately affect our roof slab, which is obviously there. So ultimately, any deformation will any deformation will be caused due to the this uplift of the soil. So this soil will always try to push, because of its swelling properties. This will always try to push this foundation, which will lead to the cracks. So as it written here, that okay, one more thing is there. So when building is constructed on expensive soil, so the soil below the building is protected from excess heat, obviously, which causes the soil to swell due to the obstruction of evaporation. So when soil is there, and it uh, seasonal variation is there, temperature is changing, heat is coming, means it is in summer season it is quite hot. When soil is in direct contact with the sun, obviously, obviously the evaporation of the soil, which is having some water content in it, when it gets dry and it reaches to a temperature of 40 to 45 degrees Celsius, obviously, and then what happens in that case is the soil will get dry. But when we make such buildings, or any foundations, or when we cover that portion of the soil which is expensive soil, so in that case, obviously, uh, the obstruction of evaporation is there, so that will lead to the shrinkage, obviously. So which will cause the soil to swell, because water is there, and it is not going because of the evaporation. So that will lead to the swelling of the soil. So and cracks and damages occurs to the floor, that I have another picture I will show you. and due to cracks utilities, these are the already we have. Obviously, one more thing is there. Yes, due to cracks, cracks utilities such as water pipes, sewage lines, gas lines may also be damaged, which can aggravate the swelling problems. Because water lines, gas pipelines are laid in the foundation. Sometimes in the foundation, electrical lines are also. Sometimes we given the earthing or anything like that in the foundation, so that will ultimately lead to the aggravate that will ultimately aggravate the problems. Okay, so we have to be careful in such areas while designing of the foundation. Okay, so as you can see, there is a on the left side you can see there is a building. This, as you can see, there is a lot of damage has occurred to the building because of the there it is, the swelling of the soil or heat is there because of the swelling of the soil. It came come this soil this thing happened. The soil came out, and there is a heat form which is formed due to the swelling of the soil. And obviously, in that case, what will happen is any on the right side you can see deformation or as in tilting of the building. This small structure occurred because of the swelling that took place in the lower region of the where we draw the where we make the foundation. So this will cause the swelling of the soil and foundation as well as the upward movement of the foundation that will ultimately lead to the any tilting or deformation in the structure. Okay. So one of the popularly known expensive soil is black cotton soil. In India, it is as I already discussed. In India, it is found in Chhattisgarh region or Madhya Pradesh region, mostly the Madhya Pradesh and Maharashtra region, and mm, these soils already discussed that Montmorillonite mineral is there, which cause such expansion of the soils. So some have elite as well as colonite also, but the major mineral which is affecting the expansion of soil is Montmorillonite. So as you can see, these are the problematic soils as from the civil engineering construction point of view. The expansion character, as we discussed about the expansive character of this soil, it increases in volume to extent of 20% to the 30% of the original volumes. And what happens in that case is, what will happen in that case? It will try to exert pressure on the building or the foundation which is there. So ultimately leads to the deformation of the building. So upward pressure exerted becomes so high it tends to lift the foundation in the upward direction. So that will ultimately lead to the cracks in walls and doors, or then it can diagonal cracking you can see. So there is a okay. So ultimately, this is we have discussed. So these soils are basically the sticky plastic clays, which are highly expensive and derived either from the residual weathering of the volcanic rocks or weathering of the fine-grained transported fine-grained soil particles, which are transported and are found in the valleys and the river banks. Obviously, these soils have great affinity towards the moisture and are characterized by the shrinking and swelling. So, uh, next slide we are going to discuss the preventive measures of expensive soil. So, what will happen in that case if we are having expensive soil and we want to we want to make a structure on such soils. So in that case, what happens is, first of all, we can go for the replacement of the expensive soil. But as you can see, in such regions, what happens is there is a plenty of expensive soil available, but there can be scarcity of the granular soil or other soils which we want to use in that area. So it can be sometimes uneconomical if we go for the larger depth. So it will be economical if we go for the small depth only, and otherwise we have to take other measures. Is it clear? So if the soil is at shallow depth, we have to remove it and we can replace this soil with the granular soil or any other kind of soil which is not showing any shrinkage or swelling properties. So, but remember this thing that it is always uneconomical to replace the whole soil. Or if we talk about the, let us say about we are making a superstructure which is 20-story building or any structure like that. So we cannot remove we just cannot remove the top 3-4 feet of the this expensive soil. We have to go in the deeper direction. We have to go deeper. So in that case, other preventive measures are also taken that we will discuss about. We will discuss in the further slides. So another method is modification of the expensive soil. So stabilization of soil is there. Stabilization means adding of lime. So while what we do is we try to add lime into the soil and try to mix it properly, and then we lay in this type of soil because lime is having cementitious properties, it has binding properties, so it will not allow uh, the soil to shrink or expand as it was expected without lime. So there is a method which is known stabilization of soil using lime. So compaction, obviously compaction. Basically, what we do is when we are making any structure, when we are constructing any structure. So in that case, what we do is we generally prefer to build this structure during the dry season when it is highly shrunk. So in that case, what we do is we can also do the compaction of the soil using. The problem arises when it is fully saturated condition. Soil is in fully saturated condition. So partially saturated, it is fine. It will not show. It will not cause much problems to us. But when it reaches to its full potential, or means full saturated condition, then it will start causing problems. So so it has to be in the dry side of the optimum moisture content. So when we do that, in that case, what happens is we can add some water in it and we try to compact these type of soils. So installation of moisture barriers. Okay. So one way of doing this is at the top of the building, not at the top of the foundation, when there is a ground level. So and at that point, what we can do is we can install moisture barriers, such as we can make RCC beams or any concrete. We can just place a concrete layer, or we can apply any uh, any mixture or some kind of thing which just oppose water repellent, water which are water repellent. So that will help us. That will help not going. That will not lead the water to go inside the soil. So that will be our moisture barriers. And one thing is that pre-wetting of soil. So pre-wetting of sometimes we do a pre-wetting of soil because in such areas when there is probability of rain or water leakage is there, or some place it is there already. So we what we do is we do the pre-wetting, means we already add water into the soil and which will lead it to swelling. So in that case, and that is also a method. So in that case, what we do is we can provide a foundation. So pressure injections and using this cement slurry, uh, we can inject the cement slurry into the ground, so that obviously its bonding with the soil increases, and it will not shrink, or it will not obviously it will not expand as it was expected. So other method is when we have to to build a foundation and a superstructure, which is a high-rise building or any multi-story buildings. So in that case, we go for the drip piers and underring piles. So this is actually one pictorial representation of replacement of extensive soil. So this in this area there it was fully covered with the extensive soil. In that case, what happens in this case, what we did was this is the region where we have replaced the soil. So replacement of soil was done, and addition of or removal of that soil, and we have replaced it with a uh, non-expensive soil. So this is also our method. So as you can see, as I have already discussed that while designing of this foundation, so what we can do in this is uh, this is just we have discussed about that a cement concrete apron with light reinforcement can be provided so that we can it, we can avoid going or we can so what will it leads to? It leads to the repelling, repelling of the water, or the water will not seep inside of this foundation part, which is basically prone to more swelling. So in these cases, we have constructed a strip footing, and in the bottom of it we provide a RCC foundation, and the top of it we are having wall which is being constructed. So this is also a plain beam that we provide on the top of the wall, and on the sides, as you can see, this is an expensive soil that is there. In that, what we do is we provide a foundation. It is having a width B. So in that case, what happens is we extend it by 15 centimeter on each side. I mean left side plus 15 and right side plus 15. Then we dig the trench and this thing happens. So we also provide air gap. So this is the ground level, and this is the RCC beam, grade beam that we have provided. So basically, what is the reason for this air gap? Because when water, if in any case water happens, water seep inside this soil, so there is a gap which is there, so that it can if the soil swells, it will not reach up uh, to the this RCC beam, and it can be stopped in the in between, which that is why we have provided the air gap. So this will, if the soil expands, it will go move up to this point, and obviously no cracking or can will be observed in such case. So this is usually constructed hot sealer that I have already told you that when soil got sunk to its minimum level. Trench width obviously 3. This is 30. Sorry, B plus 30. B is the width of the footing that we have to provide, plus 30 centimeter means 15 centimeter on both sides, left hand as well as right. So free draining granular layer has to be as it is there, that granular fill is there. So we provide a granular fill layer at the sides of this foundation and the base of this footing as well. So RCC apron having 2 meter width is provided on the outer wall of the of the building to prevent the entry of water into the foundation. So air gap over the ground surface below the RCC beam is also provided to prevent the swelling effect. And obviously, what we do in this case is this RCC apron, as you can see, uh, we provide a slope of 1 in 30, so that if in any rainy season or anything happens, so it will obviously slope will lead the water to from this side, and directly it will not uh, go beneath this foundation. So this is the reason that we also provide an outward slope in the RCC pattern. Excuse me. Okay, am I audible to all of you? I hope you are
Yes, sir.
understanding what I'm trying to say. So Is it fine? We continue with underunit piles. So shall we
Yes, sir.
continue?
Yes, sir.
Okay, okay, thank you. So now, what is actually drilled piers and undering piles are the two types of deep foundations that we can provide in these types of buildings. So when where we are having a higher load than the normal load. So in that case, what we are going to have, what we are going to do is we are going to uh, provide undering piles in the foundation. So what are undering piles? These are actually, let me just tell you, undering piles were developed by the our own CBRI, that is Central Building Research Institute of India, Roorkee. It is having a headquarters in Roorkee. So basically, and then they are basically used in uh, mostly used in commonly used in India. So under piles anchor the structure to the stable mass below the unstable soil. So deep goes in the deeper this type of deep foundations. So it will what happens in this case is this underlying piles anchor the structure to the stable mass. Obviously, if there is an upper layer of 10 meter or 15 meter is there, so in that case, what happens is we try to uh, lay the underlying pile, or underlying pile goes up to a depth of approximately more than the expensive soil which is available. So in that case, we can also avoid the unstable soil. So these piles are bored cast in situ piles. Concrete is basically made of concrete and bulb at its bottom of the. It can also have, if it is having more than one bulb, it can have in the middle also. So elevated pond piles have uh, can have two bulbs at the bottom, one or two bulbs at the bottom. IS 2911 part 3 1980 recommends a maximum of two bulbs. So I'll show you what. Okay. Okay. So basically, this is also most safe and economical foundation for black cotton soil or expensive soils. So this is just a pictorial view of underrated piles. So this is how first what we do is we try to make a bore, and using the auger we try to remove the type of soil which is expensive soil or black cotton soil which is inside. So when the auger rotates, it it removes the soil, it loosens the soil and also removes the soil. Then what we do is we insert the reinforcement and we provide the concrete layer in this. So what happens in this case is, what we have to do is there is a the reamer which we lower down from this pipe or this portion, and it will rotate and make a it will also collect the soil which is in this portion only. So and we can, then that reamer or can move in the upward direction, and then we provide the concrete layer in this area. So as you can see, this portion is known as the bulk portion of the underlying piles. So this is basically why it is provided because of these soils, when they get when water is added in such soils, so it will try to push this this pile in the upward direction. And if there is a bulb which is formed like this, and it will obviously it will try to resist the upward movement of the soil for the foundation obviously. So what happens in this case is we are using two bulbs. This is under in pile also, so it is having two bulbs. So why we provide sulfur? It is actually dependent on the type of structure, how important the structure is, or how if the soil is having a low bearing capacity or high bearing capacity, whether it can sustain such loads. If less loads are to be applied, we can go for the single under in piles. Otherwise, if the superstructure so load is so high, in that case, what we do is we provide double bulbs, and that is known as the double under-ringed piles. So in that case, what we do is we provide the two number of bulbs. So there is some provisions and different criteria for using the under-ringed piles. As you can see, and this is also a picture taken from the Kia Roda. So it is written that we have provided a bulb, and the diameter of the bulb here is, it is actually 2.5 times the diameter. This is, if this is B, the pile diameter, so it should be at least 2.5 times the diameter of the pile. And there is a reinforcement which is already discussed, that it is already lowered down, and the concreting of and formation of the, and sorry, addition of the concrete occurs, and this pile is formed in that way. So there is also a few things which we have to note down. That first one is the diameter, how much will be the diameter of the bulb, and what is the center to center spacing that we have to provide in these underlying piles from one bulb to another bulb. So it should be at least 1.5 times the diameter of the bulb itself. So 1.5 times center to center spacing of this should be 1.5 times of the diameter of the bulb. And where we are going to provide the bulb, it is also specified that it should be at least 2b1. B1 is the diameter of the bulb. So it is, if it is, for example, if it is 500 mm, so we have to at least go for or 2b1 minimum, or 1750 mm for expensive soils. So these are the things that we have to take care of. This is also, let us discuss about the different criteria for under-ring piles. The minimum length of pile should be at least 3 to 5 meters below the. It should go below the ground surface at least 3 to 5 meters. In case of shallow depth, the length of pile may be reduced, but the pile shall not be at 60 centimeter in the. At least it should be, if in any case rocks or any stable foundation is there, so in that case should not be less than this 60 centimeter in the stable zone, not from the top of the ground level. At least it should be at least lower down to the 60 centimeter in the stable zone. The diameter of bulb, as we already discussed, that it can be 2 to 3 times shaft diameter, and these things we have already discussed. So okay. So, what are the uses of these piles? So, to obviously to avoid the undesirable effect of seasonal moisture changes in expensive soils, to reach hard strata, obtain adequate capacity of downward uplift and lateral loads and movements. Obviously, when these how these loads are acting on the structure, uplift load will be due to the swelling of the soil. Lateral load will be sometimes when we have high-rise buildings, due to the application of the winds, due to the winds, and due to the winds, lateral loads are also provided. So also applied, and these lateral loads ultimately leads to the uh, to the to the uplift of the these piles. And when sometimes when earthquake is there, so earthquake comes, in that case what we do is these forces are also applied, lateral forces are also applied. So these underlying piles can easily take such loads when it is provided the any foundation. In the building. Okay. So to take foundation below the score level, okay. And then one more thing is there. So if any building is there, it is prone to some. Prone to any this scoring. So in that case, we can also provide so that the score level can be avoided, and it should be provided below the score level. So underlying piles used under conditions where obviously it should not be, underlying piles should not be used where vibration and noise cause construction of the during the construction of the pile. This is to be avoided in such cases. So okay, so let us, okay, did I miss? Okay. So the first portion of the presentation is over, which was expensive soil. Now the second portion of our um, presentation is collapsible soils. So let us discuss something about the collapsible soil. Please excuse me for a second. Okay. So let's discuss about the collapsible soil. What are collapsible soils and where they are generally found? So soil that undergoes, according to Sultan 1969, said that soil which undergoes an appreciable amount of volume change upon wetting. This soil does not have this shrinking or any properties, but uh, the thing is, when we add water, it goes up to the saturation level, then appreciable amount of volume change occurs in this type of soils. So either we fully saturate the soil or wet the soil, or other thing is by load application. At a particular point, at a particular up to a particular point, it can take load, and then what happens is in that case, if we applied more load on these type of soils, a sudden this collapse of the structure or of the soil structures take place, and the sudden collapse of the soil occurs. So so there are the two major reasons. Obviously, first one is the saturation or the wetting of the soil, other one is the load application, or it can be due to the addition combination of these two. So these soils are generally wind deposit soils which have low water content and high wet ratio in natural state. These, okay. So collapsible soils show high strength and stiffness at normal water content conditions. When when these soils are not when the surcharge load or any kind of load application is not there. In that case, and so if the soil is dry, then they shows that they are having a high strength, and obviously the stiffness of their soil will be high. But when it reaches to the saturation level, a sudden collapse occurs, which could be severe in some cases. Okay, so most of the collapsible soil are cohesionless soil, but they have a very small coating of clay or other binding materials. One of the most commonly found soil is the loess that we will discuss in the coming slides. So let us discuss about the key characteristics of the collapsible soils. So we will these are the two factors that affect these type of collapsible soils. First one is water infiltration, another one is additional loading. So these type of soil generally having an open structure, and they basically are geologically they are young. If they are actually removed or they are moved from the parent soil, that is why it is known as the soil which are geologically young, and it is showing some uh, color which is light brown. The as a parent material, it is dark brown. So these soils are geologically young as compared to the parent soil. So obviously it is having an open structure, high sensitivity, and low interval that we will discuss in the coming slides also. Uh, Significant volume change at full saturation or near saturation level. When it is fully saturated or any saturation level is reached, in that case, what will happen is this significant volume change will occur. So this is the family of collapsible soil. So collapsible first one is we have to classify these collapsible soils. So first one is the compacted soil, another one is the natural soil. So we don't have any problem with the compacted soil. It will be found in the region glaciers only, so it will not get transported. So the problem starts with the soil which is natural soil. So it can further classified into residual soil, sediments, and slide structures. So residual soils are formed by weathering and decomposition of the rocks and are basically not transported from its original place. And these are the sediments that get transported from their natural state. And this is a slide structure. Slide structure basically is this sliding of the structure, or means the due to gravity force which is acting on the structure. So in that case, this basically form these soils are basically formed due to the sliding of any rock mass in the glacier level. So in that case, gravity action is basically the predominant one. So let us discuss about the sediment. So it can be either transported by the water, or it can be either transported by the air. So, and this basically just now stated that major weathering is occurred due to the gravity action in this. So when mm, transportation occurs with the water, these soil get transported with the water, then is the formation of leads to the formation of quick clay. This is actually a special type of clay which totally collapse and flows like a liquid when overloaded. When overloading of this clay or this soil is done, a sudden collapse, this a total collapse, or it will flow like a liquid. So this is known as the quick clay. Actually, these type of quick clays or collapsible soils, you can say, is generally found in Norway and Sweden. And in these type of soils, we have minerals such as kaolinite and illite. Okay. So now other one is which is the sediments which are transported by the water, and another classification of it is alluvial deposits. So basically these are the most fertile soils which are available near the, obviously, yeah, these are transported by the waters. So another one is, we will discuss about this in the coming slide, and this one is the another one is the flood deposit. So flood deposit, basically it consists of sand, silt, clay, and carried uh, by the slow moving waters. Or after the flood, we can say that after flood, uh, this spreading of the soil take place in the low lying region areas. Means when that is why it is known as flood deposits. When flood in any area comes, so the during the flood, these soils get got carried away in the adjacent areas. So these are found only in that area, which are not actually not transported along with the rivers or the water. So these are actually different these are having some difference with the alluvial deposit. These are carried away with the water along, means Ganga river or any river which is carrying these deposits, and these are basically transported with the water. But this is due to the when some sudden flood is coming in that area. So the particles which are having size higher than the and are not easily transported, they need some force. So during the flood it got deposited. So now the sediments which got transported with the help of air, first one is loess and other one is volcanic ash. So this loess is the uh, this is the most of collapsible soils that we have, and this is slide structure leads to the this is basically due to the gravity, and it will ultimately lead to the deposit of the colluvial soil. This is basically weathered material and transported by the gravity actions. Okay, so let us discuss about alluvial soils. So Alluvial type collapsible soils are mainly formed by flash flood or mud flows, so which comes from huge precipitation in the irregular intervals. Obviously, when this mud flow or debris flow occurs, so in that case, these soils get transported and are deposited in such areas. So loose and metastable, I will discuss about this metastable condition means which is actually in stable condition for a small period of time until or unless we add water or we apply any load on that type of soil. So that state is known as the metastable state. So obviously it is formed in the loose state and it is not having in the because from one soil particle to the other soil particle there is actually a gap. So it is held by the mining bonds. So that we will discuss in the upcoming slides. And loose and metastable states are induced due to the particles which are transported and deposited suddenly or locally. Alluvial deposits are poorly graded and may contain a considerable amount of clay, which plays an important role in binding of these particles in dry state. So another one is Olean deposit. So this is actually that we were discussing about the this alien means the deposition of this happens due to the air. So this is what known as the Avalanche deposit. So loess is actually a soil which let me just okay yeah there is a formation of loess. So let me just discuss about this first, then we will discuss about the previous slide. So for me, how this formation of loess occurs, it is actually as discussed that it is a yellow to reddish brown silt size soil which is having a uniform grain size. Now, what happens in this case is the fine particles, silt particles actually, they are carried away by the wind and beyond the desert area in the region where there is more humidity. So there is humidity variation is there, and the climate is more humid. Then it goes to that area and try to settle down in that area because of the wind coming from the other direction. So this is actually transported by the wind, and where there is vegetation or there is more humidity from the other way wind is coming, they collapse and it will try to settle down in that area where vegetation is there is a region of vegetation. So these soils have high vertical permeability, which vertical permeability which leads to the rapid saturation from rainfall. This is these soils have relatively low density and cohesion, but appreciable strength and stiffness in the dry state, as it proved to be a good foundation material under unsaturated conditions. So this has to be noted down that under unsaturated conditions, this type of soils can be used as a foundation material. If there is a dry region and water is not a problem there, so in that region, what we can do is we can use it as a foundation material. So this is actually a theory as an image of how a unit of lowest looks when it is under the microscope, when you look into the microscope. So this is actually a sand or you can say a silt grain which is there. So there is as we have discussed that these basically have a silt particles or it can have sand particles also, but the major portion of this is having silt particles. So they are bonded by some cementitious substance or clay or any other substance. So these bone cementing bonds are not that much strong, but they ultimately holds the silt particles together until or unless um, there is application of higher load or there is an wetting of the soil. So this is actually pure view of this. So this is actually kind of soil that it looks. It is solid sand or silt particles are there, and there you can see there is clay particles are there which are flaky in nature, and these are basically for the cementitious or the binding of these particles and drawing these particles together. This is actually an enlarged view of a very small portion of soil. So this is how formation of Lewis occurs. There is a glacier there. So when due to the winds, these soils get deposited, which are deposited here, and they get transported to the region which is having a higher humidity on the vegetation region, as you can see here. So these soils will move with the wind, and there where there is a vegetation or high humidity, so in that case it tries to settle down in such places, and you can see a mountain of these type of soils. So these soils are not just a type of soil that you can see in the deserts. It is actually forming a mountain of its own. So I will show a picture of that in the upcoming slide. So let us first discuss about the gradation curve of the lowest this soil. So as you can see here, this is axis. This x-axis is for the particle size, and y-axis for the percentage final. As we take this type of soil and do the gradation of it, and after the gradation, we can see that actually I was more focused on this because as a student of mine just went for a for exam in Himachal Pradesh last week only. So in that paper, a question was asked that what is the most uh, mm, what is the particle size of the uh, that type of soil that is this collapsible soil. So in that case, it was the lowest, and in lowest it is around 60 to 70% silt particles are there. As you can see, uh, that silt content in this is quite high. This is the logarithmic axis. The particle size is there. So clay particles are not present. Very few, if they are present, very few amount, and obviously these sand particles are very also limited. So most of this is having a silt content, and it covers around 60 to 70% of the silt, and obviously less than 5 to 10% clay particles, and it can have sand particles also, but major portion of this is consist of the silt content. So this is image. As you can see, this is a mountain. So this is a picture of thick loess deposit in America. So I don't I think that you can see there are actually at the roots of these vegetation when there is a vegetation or these small trees are there. So in that case is what happens in this case is Lewis, as discussed in the earlier slide also. I think I have discussed this. Mm, Let me just see if I have discussed it or not. Okay. Okay, no, that is not a problem. So this basically is these when they get transported and they form a mountain near the roots, they are having a pipe. Means vertical when we add water in these type of soils, what happens is because of their vertical uh, pipes or vertical, as you can see here, vertical lines are there. So as you can see here also, so there are vertical lines which makes them more permeable in the vertical direction as compared to the horizontal direction. So because of this, this vertical pipes, or you can say the vertical words like word line is there. So at the this roots of the vegetation. So in that case, what happens is when water is added or water there is an rainfall or any reason when water is added in these soils, the because of the high permeability in the vertical direction, so it goes down. Goes down in quite less number of time. Obviously, silt or sand is a soil which is having high permeability, but this specifically Loess is having high permeability in the vertical direction. So this is a mountain of Lewis which is formed, and obviously it is transported through the wind. So it got deposited, and naturally the compaction of this happened, and after some certain time the vegetation was there. And this picture was taken from a presentation by C.R. Goyal. So this is a huge. This is also a huge deposits of Loess. Another picture in US, it is California. So as you can see, this is actually when, as I have already discussed, and when in dry state, it will provide a good foundation support. So it will not cause much problem when it is in dry state. So as you can see, this looks like it is a stable material, and but until or unless we provide heavier load on these type of mountains or these type of soils, they are going to be just fine, and it will behave in the normal way. But obviously, the shearing resistance or the load carrying capacity of these soils are obviously less than the soils which we have, means the mm, sand or as a mixed material. So obviously, the dry density of this is also less, and shearing resistance of these soils is also less. So. Okay, so these are the this is the metastable condition of a collapsible soil. So what is metastable condition? Means it is in a stable condition until or unless we add water. So these are the silt or the sand grains. So these, as you can see, it is written there that we have silt or sand grains. And they are held by these are the bonds which hold them, and or you can see the small clay or any bonds are there which just uh, clay bond or carbonate bond or some bonds which just hold them in place until any deformation occurs. So these grains are not in contact. So the soil is behavior of the soil is controlled by the structure and the strength of the holding bonds, and obviously it is not very high. So open packing of the grains honeycomb structure collapse will cause packing to become closed. So okay, in the next slide, I am going to show there actually there is two types of collapse of if collapse occurs in the inside, it occurs in the inside direction, then it will be known as the collapsible soil. If the collapse of this soil happens in the outside direction, then it will be known as the dispersive soil. So there is a small difference between the collapsive soil and the dispersive soil. So if we are given this metastable condition, so this is condition. If all the particles starts to fall in inside of this region only, so that will be our soil will be known as the collapsible soil. If these soil particles starts to move in the outward direction or collapse in the outward direction, in that case, if the uh, soil forms, that soil will be known as the dispersive soil. So but here we are also focusing on collapsible soils. So as you can see, there is a loss of volume upon collapse. That collapse after collapse this happened, and the loss of volume is it is there. Holding bonds have been destroyed by the triggering event. So triggering event basically means the addition of water or any addition of the load. So this is a collapsed state of a collapsible soil. So this is actually behavior of a typical loess upon wetting. So as you can see, it is obviously having a high void ratio. uh, this x-axis shows the stress, and this y-axis shows the void ratio. So this is the void ratio, but this red line here is showing that it is the soil. Both soil samples were taken. One is pre-wetted and other one is wetted. Uh, so the state, as you can see, it is having a high and particular stress value. So at this particular stress value, the void ratio is quite high. But with respect to the wetted soil, the void ratio decreases when it is wetted for some time and we started applying load. So maximum stress that is has taken, for example, it is 10, let us say at 10, it has a void ratio of 0.65 with respect to the soil which is not wet, and it is having a void ratio of 0.83, some it is around 0.83. So but ultimately what will happen is, ultimately it will the void ratio, because of the collapsing of the soil, the void ratio will reduce, and it will go as down up to 0.3, but not in the case of the other soil which is not wetted. So it will maintain a void ratio of around zero point 0.5 to zero point 0.5 to point somewhere between 0.6. So there is a huge gap, a huge variation in the void ratio when it is wetted or it is dry conditions. So what are the triggering factors that cause the collapse of these type of soils? So there are various factors such as irrigation of landslidings or crops. Because of this addition of water into for use for the irrigation purposes, this, if there is a soil present below that region, so in that case, what will happen is, if we add water, obviously collapse of the soil will take place, because these soils are not having high strength and cannot take uh, much load, as well as the wetting will also cause the collapse of these structures. So changes in surface drainage of rainwater, rain or leakage from unlined canals, pipelines, swimming pools, any kind of leakage will lead to the collapsing of the soil. And if some structure is built on it, obviously it will also lead to the collapse of these structures. Okay. And such wetting can also lead to the large scale collapses. Another, let us now say, how can we determine the collapsibility of this? So there is a formula there which is known as delta H by H is equal to, delta H is the change in height upon collapse. And how can we determine this? This is actually determined with the help of the audiometer or the simple consolidation test that we perform in our laboratory. So with the help of that test, we can calculate this collapsive coefficient of collapsibility. So that coefficient of collapsibility is delta h by h, which is change in height upon collapse divided by the original height. So and it also denoted by, also there is one more formula, it is delta E upon 1 plus E. Delta is the change in void ratio upon collapse, and E refers to the void ratio prior to collapse. So if we can calculate this coefficient of collapsibility, and it is between 0 to 1, then there is not much of a problem at all. So we can avoid that. If it is between 1 to 5, there is some trouble when we have to deal with it. And if the range is between 5 to 10, obviously we have to go for the some measures. Similarly, 10 to 20 severely trouble, and if it is greater than 20, obviously either we have to remove it or we have to take strict measures to remedify the situation. So, what are the how this can be mitigated? So, there are basically uh, structure considerations, site features, collapsible soil, avoidance and ground modification. So, structure consideration means residences are usually supported on shallow foundation. In that case, what we do is, mm, and if these footings are lightly loaded because the soil is having low bearing capacity, we can provide uh, this strip foundation or this shallow foundation, or in that case, not in this case, we do not provide strip foundation. We provide mat type of foundation in this case. So it will cover the large area irrespective with respect to the strip foundation. So in this case, when we have to build a residential area or in any such areas, so we have to provide a mat foundation, uh, not the strip foundation as used in the is expensive soil. So this is a bit different from the that kind of soil. So these things should be side feature includes that properly compaction of the soil takes place, and Lands, landscape irrigation should be restricted or eliminated. Foundation drain and water features should be underlain with an impermeable liner to prevent the water from seeping into the soil, as it is clearly written. So but obviously, the thing is that if we can avoid such soils, we should avoid such soils. But if there is a thin deposit, then we can remove that. But if it is obviously if it is thick, then we have to uh, go for the other measures. So these are the for the ground mod. How can we do the ground modification in this case? So ground modifications can be used to prevent collapse from occurring, and they can also be used to induce the collapse prior to the development. So the following measures are to be taken on metastable soils that may be wet to depth of 2 meter or less. So first one is the pre-wetting of the soil. Obviously, if this is actually when we have to use this, we have to build a foundation or on or any superstructure on such soils. We should first pre-wet the soil. So pre-wetting will lead to the obviously lead to the collapsing of the soil. So after that, we can compact it with using the heavy rollers, and we can use the heavy or having damping can also be done, so that ultimately there will not be a problem for us in the future. So this is important one, pre-wetting of the soil. Pre-wetting will lead to the collapse of the soil. And ultimately, in the longer period, it will not cause much problems. But it will make our structure or any foundation on a soil which is dry, and in any case, water appears into that soil, seepage occurs, or any other things, that will lead to the obviously that will lead to the collapsing of the structure after we are constructed on the structure. So uh, that is not admissible. So we should first pre-wet the soil, and then using the compactor or heavy rollers we can do the damping. To treat the soil, this is also one of the methods when we can improve the soil. This can using this calcium chloride or calcium silicate solution in order to introduce the cementing, which is insoluble. So, let me just, ma'am, am I audible, ma'am?
Yes, sir.
Should I continue?
Yes, sir. Yes.
Okay, I have time, no? So, okay. So let us discuss one case study that is this is the case in US also. US also. Actually, I have taken references from some slides or PPT which is already there, but included some parts from some of them, and so this was a presentation which was from someone from the US. So I have also taken the reference of that. So now this is a case study. This is in Colorado. So what was done in that case is the town of Glenwood Springs lies on the colluvial soil that we have discussed. Colluvial soils are formed weathered material which are transported by the gravity action. So these are generally found at the base of the hill slopes, or formation of this will be due to the rain wash, or as you might have seen, uh, some what you can say that some aggregates or stones are there which are washed, which comes with the uh, after the rain and at the bottom portion of the hills. So these are the stones, or if you can say the sediments which comes after uh, um, it comes at the this hill slope levels, the base of the hill slopes, and uh, and let me just show you this. This is the picture of this. So this is, as you can see, there is a loose material. Loose material is there. So what was done in that case is this is actually formed on the colloquial soil, that we have discussed. So what the builder has done in this case is he has made a two-story building, and it is approximately 13 buildings he has made, means one, two, three, four, like that. So 13 two-story buildings that was constructed on this type of soil. So a wall was constructed just to stop the set these when so this vegetation is also there. So a wall was constructed which can stop the debris from coming in this area. So these soils are highly susceptible to hydrocompaction. Hydrocompaction here means when in case water, any water is added in these soils, or wet water comes into these soils, so compaction of uh, that will compaction of that soil will occur, and obviously uh, that will cause problems in the future. So this is that we have discussed. So um, and it was constructed, and later on it was found when rain in the rainy season, these buildings started showing some problems, like significant errors were made in the design and construction and grading and landscaping. So one more problem was there that the back of the units did not have, means the construction houses did not have proper drainage, and rain gutters were also not provided. Rain gutters were actually, we provide rain gutters on the top of the any building, so that the water can be collected into these gutter and can drain off easily. So these rain gutters were also absent in the from the roof line in these buildings. We did not have any proper drainage. So if we do not have any proper drainage system, so soil, that water will obviously go into the foundation, and it will start causing problems. So these units were built between 2003 to 2003, and within 6 months of the first units completed and sold, collapse of the soil was causing settlement of the back concrete wall foundations. Obviously, so let me just show you the images. These are the images of the that same story building, the two-story building. So these are the cracks that has appeared on the side of the doors, and sometimes at the side of the windows, because of the absence of proper drainage system, or absence of the this, as said, that absence of these rain gutters, and because of the absence of this, it leads to the development of the cracks at the house near the uh, door, and as well as at the this windows also. So interior cracks, structural offsets, and distortion of windows and doors appeared. So, what was actually finally done? So, from certain areas which collapsed during the addition of the water or the seepage of the water. So compaction grouting was done in that areas to lift the settled areas of the building. So that was the final decision taken the by the developer, so that finally they have to do the compaction grouting. So using that compaction grouting, the slurry, this cement slurry mixed with sand and was added in the foundation, and which which ultimately lifted the settled areas, because in this case no expansion will occur. In this case, collapse of the soil will occur, and obviously the density, the volume will decrease. So we have to lift the settled area. So using this compaction routing, we they have lifted the settled areas. So this is one more picture. And as you can see that inclination of the beam also occurred. So deflection of the ceiling beam due to settlement of the wall. So when the wall settled, in that case, this also got tilted and deflection was can be easily seen in this building. So this that was the case study. Now, numerous case studies are available to us. These are the references that I have used in this particular slide, this presentation. K.R. Arora. The book, it is the book, Soil Mechanics book, and this F.H. Chen, 1998, Foundation on Expensive Soils, and C.R. Goel, and finally L.A.L. Hayek at all. So this is also, and this is actually a uh, joint research program was specially done on these type of collapsible soils. So this is in the Purdue University, that is in US. So in Purdue University, this joint research program was taken from this. I have taken various references. Uh, I thank you all for your patient listening. If you have any questions, please, ready to give answers. Thank you all of you once again. And if you, ma'am, this is my email ID, Pankaj Bajaj 522 at gmail.com. So if you need any uh, if you have any questions in mind, you don't want to, obviously, you can ask to me right now. If still you feel in some times afterwards, you please note down my ID if you have any queries regarding this or the work which I have done in my PhD, or anybody who wants to work in the same direction. I can, obviously, I'll be more than happy to help. That is it from my side. Thank you all of you once again.
Thank you, sir, for a wonderful session.
Thank you.
Sir, how can we deal with the challenge of this expansive soil, because we cannot stop constructions? So,
Basically, ma'am, that I have discussed that various remedial measures that we have to take. So remedial measures include the most proper, commonly used method is the underring pile. So if we construct underring piles in such areas where we are going to have uh, deeper foundations or a foundation which are having more load. So in that, in structures we are having more load is applied from these structures, and that area we should go for the underring piles or the drilled pier. There is also one topic which is drilled pier. So in that area we try to move ahead with either underring piles or the drilled piers. So there are with different drill piers also. They are having simple drill piers and one bell or the bell drilled piers are also there. So what they do is they help the soil, they help the foundation uh, not to move in the uplift when the uplift forces are applied from the soil. So they still remain because of the bulbs. They still remain in their place. So if we have to construct a heavy building or such cases, we have to go for these type of foundations. So these otherwise we can simply remove the top portion of the soil and remove that soil with the uh, non-expensive soil simply.
Sir, recently I came across a case in which there was some building that was going underground, and then some people used some jack and they were trying to bluff it.
Basically,
Sir,
ma'am, there is one thing. Uh, it can be due to this presence of the soil, or sometimes simple soils which are not properly compacted, and they are also undergo settlement. So first, we have to see which type of soil it is. If it is simple soil which is there, and it is non expensive soil is there, or any collapsible type of soil is there. So if it is not there, and we do not provide, you might have seen, everyone might have seen that while making our houses or any of the building, we provide the compaction. So if we don't provide enough compaction to the soil, settlement definitely will occur. So that is the one case is there. The Tower of Pisa, you all might know that that is also a case of differential settlement. So in that case, there is no expensive soil or any kind of soil is there, but simply while making making its foundation, so the compaction was not done properly. That leads to the differential settlement. So if we have soil which is not having major problems, so if we still don't compact it, it will obviously lead to the settlement in the near future. So that depends on the type of soil also, and how we provide the compaction to the soil.
Hello, Pankaj
Hello,
sir, Naseem here.
hello, sir, Naseem sir. How are you?
How are you, sir?
I'm fine, thank you.
Very good for presentation, sir.
Thank you so much.
I have two questions.
Okay, sir.
First question is how to deal with collapsible soil before building construction, and what type of foundation is suitable for the collapsible soil?
Okay, sir. Just I have discussed this in the slides also. First one is second. Your second question is what type of foundation we provide in the
Hmm.
collapsible soil. So in collapsible soils, first we pre-wet the soil so that the collapse of the soil can take place before making the foundation. If already the collapsing of the soil take place, it will not cause much problems in the future. So in that case, what we do is we generally recommend the mat foundation,
Okay, okay, okay.
mat type of
And
foundation. Okay. So sorry, your first question was, can you please
how
repeat
to
once
deal
again?
with collapsible soil before building construction?
Collapsive soil.
Before building construction.
Collapsive soil subject, I just said that before building we have to
Construction.
pre-wet the soil. Yes, pre-wetting will lead to the ultimately it will lead to the collapsing of the soil, and after collapsing of the soil we can make our this foundation. So it will be better if we pre-wet the soil, or and after pre-wetting, what we do generally in this case, what we do is we do the compaction at that instant only during the heavy compactors and the dampers we have. So after compacting it properly, it will not cause much problems in the future. So that is the thing that we do in the collapsive soil.
Okay, thank you, sir.
Thank you so much.
thank you, sir, for a wonderful and elaborative session. If the participants have any questions, they are encouraged to unmute yourself, or you can even type in the chat box. And if you want to interact personally, you have the email, sir's email with you. You can contact him anytime. I'm
I have
sure he
I
will be
have my
glad.
PhD in I have my PhD in better piles and pile foundation. So anybody who is having any doubt regarding that field also, regarding any better piles, or I have published some papers in better piles. So if we can go through these papers as well. If you have any doubt in that topic as well, you can write a mail to me, and I will be happy to answer all of your questions. If you have questions regarding this presentation, you can ask right away.
Sir, I don't see any questions in the chat box as of now. And if the participants have any raised in the later case, I think they will contact you directly.
Sure, ma'am, sure. Hmm.
Thank you so much, sir, for a wonderful and elaborative session. And we hope to see you in future again, sir.
Thank you so much. Thank you so much, ma'am. It was
Thank you so much.
nice. It was nice having you all. Thank you so
It
much.
was a pleasure to interact with you, sir.
Thank you so much. Thank you.
Thank you so much. So that was the second session for today, and we hope to see you after a lunch break at 2 p.m. for the next session. Thank you, participants.